someone asks, how do you get there? What do you say? Do you tell them about the packed train compartment? Or how you have to leave when they want you to leave? Do you tell them you got there 2 hours early just to sit and wait? Or about the excessive amounts of pollution, the endless queues, the accidents, congestion, overcrowding, inefficiency, how antiquated it all is? We're Hyperloop One, and we're going to change this.
Please welcome Nick Earle.
You know, there's a phrase which all students of history learn, which is geography is destiny. And what that really means, it's actually not a positive thing. What it really means is that small countries are destined to remain poor. It means that if you share a border with a larger country, you're destined to remain in the shadow of the larger country. And if where your country is far away from where the markets are, where you want to sell your goods and services, then you will always be at a disadvantage, unless, of course, you have some advantage in terms of natural resources. And then the question is that a sustainable competitive advantage? In his book, Connectography, Parag Khanna, who grew up in the UAE, says that actually all of that is changing, and because of the tremendous progress there's been in connectivity, and he quotes examples like energy, infrastructure, oil pipelines, highways, railways, particularly the internet, that actually it's not so much geography that is the big determining factor anymore, it's actually connectivity. And actually maybe connectivity is now the biggest driver of destiny. But if you look at that list of connectivity capabilities, I think we'd all agree that they're not all the same. Now, I was 13 years at Cisco, and I saw the broadband revolution at first hand. And, you know, clearly digital connectivity has come forward in leaps and bounds over the last 40 years. But physical connectivity, be it road journeys, be it the shipping process at the port, be it the airplane journey, or my own personal favorite, the rail journey. Steel wheels on steel rails, a system that was invented in 1830. The more roads we build, the more crowded that they get. It seems like physical connectivity has so far been unable to take advantage of the benefits that as a society we've created with digital connectivity. Now, we believe that we stand a chance of changing that. We believe that it's possible to create something that looks like broadband, but broadband for things. Instead of packets, data, voice, and video packets, what if it was people, freight, cars, broadband for physical things? What if it was on demand? It didn't leave when it was meant to leave according to a schedule. It leaves when you want to leave. What if it was personalized? What if it was autonomous? And critically, what if it was direct to destination? Why does it have to stop at all those places you don't want to go to? Why can't you go direct, or your goods go direct to destination? Now, at Hyperloop One, our vision is to actually do just that, is to try and create physical broadband. And yes, it's about speed, but it's more than just about speed. We talked about Dubai to Abu Dhabi in 12 minutes, Helsinki to Stockholm in 28, which, by the way, involves a significant stretch of water and currently is a 17-hour boat ride between those two. Delhi to Mumbai in 78 minutes, got a lot of attention in India, and Melbourne to Sydney in 55 minutes. But it's not just about speed. It's actually about totally changing physical transportation. So that's what I want to talk about today. I'm going to, first of all, talk about what is Hyperloop, sort of a primer, so everyone's on the same page of what is Hyperloop. Then what we'll do is we'll go deep into some research that we've recently concluded, which is around what could the effect be if this were to happen on supply chain and distribution. Supply chain and distribution that accounts for 5 to 10% of the turnover of manufacturing companies on average. So if you're a manufacturing company with $1 million turnover, this is a $50,000 to $100,000 problem. If you're a $1 billion turnover, it's $50 to $100 million problem. We'll take a look at multiple data points that we've concluded in a major piece of research that we released today. about what the potential could be. And then we're going to finish with the question on everybody's mind, which is basically can be summed up as, yeah, but is this really going to happen? I mean, really? Is this really going to happen? So I'll open the kimono a little bit on where we are and what's going to happen next. So let's get started with that first one. What is a Hyperloop? Well, it all started in 2013. This is a pretty famous story. Elon Musk is in a car in southern Los Angeles. He's stuck in traffic. He's really frustrated. I'm based in London, and I go to LA all the time. I get stuck in traffic all the time in LA. And he's looking out the window. He sees the planes going faster. He's very frustrated. And he's also thinking about something that was on the radio, which was California high-speed rail. Tens and tens of billions of dollars. It was going to go apparently from San Francisco to LA, but it was going to be many, many years. It was going to get stuck in the regulation process. And even then, it wasn't going to come into the city, because high-speed rail just needs so much land and clear the buildings in order to get in. And he thought, this isn't going to solve the problem. So he wrote a white paper. He postulated that something called a Hyperloop would be possible. He open-sourced the idea. He open-sourced the name to the world and said, have at it. And we formed a company which I'll tell you about, called Hyperloop One. Now, what is a Hyperloop? A Hyperloop is essentially 5 pieces of technology that come together. The first piece of technology, there's a passenger or a cargo pod. There's a vehicle, a passenger, or it can take passengers, it can take cargo, it doesn't matter what's inside of it. The second piece of technology is that it exists in a low-pressure tube. Actually, we're building it to be 99.9% vacuum. For the engineers in the audience, that's 100 pascals, or equal to the air pressure at 160,000 feet. Why do you want to do that? Because you want to take the air pressure resistance away, so once it's moving, it glides. By the way, you can do that with standard off-the-shelf vacuum pumps. The third piece of technology is electromagnetic propulsion. So a custom-built, this is where a lot of the intellectual property is, a custom-built electric motor. So instead of a motor that goes round and round and round, it's a linear motor that goes forward. And then what you have is passive maglev. Passive maglev means instead of like the Japanese high-speed rail, 100% of the track is electrified. You only use electricity just in front of the pod. Just as the pod passes over, you pulse it. So it's like one of those buildings where you go down the corridor and the lights go on and off above your head. And what that does is it causes a magnetic differential, which causes it to lift. So you have forward motion, you have lift, you have no air pressure, and then it moves. And the final thing, and the thing probably that most people talk the least about, but I think is potentially the biggest single one, is you have an autonomous control platform. Why is this important? Because if you think about your iPhone or your Samsung, it's not the actual hardware that determines your experience, it's the software. So the control platform is the iOS of the Hyperloop, and it'll have a set of open APIs, and there'll be applications on it, just like there are on your iPhone or your Samsung device. Now, once you build it like this, you then can build it in different sizes. So we're thinking about 3 models: shipping containers, freight containers. I'll give you an update on that. The most popular one that we're seeing is the one in the middle, just under 4 meters diameters for passenger and light freight. And it is possible to build a much smaller one for a sort of courier-type mail, though so far it's really number 1 and number 2 is where there's the most demand. Now, the IT platform gives connectivity. This is something the rail industry never had. If you think about it, there are multiple parts of the world where you have to get off a train and get on a different one because you've got a different gauge, for example. So we're building the IT platform for interoperability, which means that you can order a multimodal journey, a bus, a metro, a Hyperloop, an autonomous car, with 1 click of your phone. So we're opening up the platform for interoperability so everything can be done on demand through the phone. Call an autonomous car, comes to your house or your office, takes you to the Hyperloop station or portal, takes you through the tube. At the other end, the airlock opens, takes you out of the tube, takes you direct to destination. Direct to destination in a fully autonomous journey where the destination could be 800, 900 kilometers away. You could take an Uber from here to Jeddah, for example. So once you've designing this platform, you can then say, well, if I'm going to build broadband, then I want packetization. Data packets, voice packets, video packets. So you have a transporter in which you put the packets, and the packets could be cargo, passengers, or car. So you get the basic idea of the building blocks. Put them all together, and what you get is several things. The thing that everybody talks about is speed. Everybody wants to know, how fast will it go? Well, the answer is really fast. We did a lot of press today, a lot of questions about this. We're building it for 1,080 kilometers an hour. That's just below the speed of sound, very deliberately, because you don't want a sound wave in the tube. There's no vibration in the tube. There's no noise in the tube. It's very green, but you don't want to create a sound wave. That's 300 meters a second. Now, straight away, people say, will your face peel off on a Hyperloop? Actually, no, because human beings don't feel speed, they feel acceleration. The acceleration from standing still is 0.3 of a g. That's about the same speed as a small car would join the highway here between Abu Dhabi and Dubai. A Tesla, which is past regulatory approval, does 1.2 g, to give you some indication. So it'll feel just a bit like getting in the elevator at Burj Khalifa or just accelerating a car. We actually think you can stand up, and we think the experience will be just noticeable, but certainly you won't feel speed, because it's just like an airplane, except we bring the air pressure down rather than send the airplane up. So then when you start comparing speed, you start thinking, well, how does that compare to other things? Now, I like to call this a very optimistic chart. I've done the journey that's there, Dubai, Abu Dhabi. I've done that many, many times. I can tell you the record I've ever done by car is 1.5 hours, which is very, very early on, before 6 o'clock in the morning. But like you, I'm sure there are many of us who've done that in a 3 or 4 hour type journey time. And so whichever route that you look at, this is an order of magnitude quicker. But it would be a mistake to think that Hyperloop is about speed. It's also about connectivity. Anywhere in the GCC to anywhere in the GCC for under 90 minutes. Now, in case anybody's out there that's doing the maths and say, hang on a second, if I add up those little things, it comes to about 130 minutes to get from here to Mecca. Actually, that's because it's the individual journey times, which includes the speeding up and the slowing down. But if you went direct, remember, every journey, your individual journey is different to everybody else's individual journey on the network. If you went direct, that is, actually, it's about 70 minutes, but we call it under 90 minutes. If you look at what happened to Singapore, 7 million people, and how they transformed their economy without a huge manufacturing base through connectivity, then you see the opportunity for the GCC to actually be a center of next-generation connectivity. And I think that's why there's so much interest from pretty much every country in the GCC in building a GCC network, not just the study that's had the most publicity, which is the Dubai to Abu Dhabi route. So yes, it's fast, but there's some other things that make it different as well. It leaves on demand when you want to leave. It's not like a train every hour, 1,000 people leave and it stops at every station. It's whenever you want to leave. Your pod leaves when you want to leave. It coexists with existing modes of transport, either through the app or, as you can see from the picture, because it's got such a low footprint, you can actually superimpose it on existing transportation hubs. And critically, for me, the single biggest differentiator, it's direct to destination. Every journey is direct to destination. So let's just take a look at that. Typically, journeys, let's take a really simple journey. You want to go from A to B, and you have a high-speed train or a metro or a car or whatever goes to A to B. But very, very rarely do you want to go A to B. There's always some other places that you want to go. If you try and connect those with, let's say, a high-speed rail network, which is the thing we get compared to the most, it's actually very, very difficult. You end up with a sort of spaghetti crisscross of straight lines. The thing about the Hyperloop is that not only can you connect them very easily, we call this branching, but actually, no matter where you want to go, you can go A to B direct, but you could also go just to the commute zone or the commute zone to the regional or the start to the new city or whatever it is. Every journey is just like the way your phone works. It's like the way your PC works. The packets have an address on them. They only go to the destination. Packetization of physical transport will change business models in a way that's not been possible before, which is what we're about to see. So if transportation is the new broadband, and that's really the big idea here, if it's the new broadband, then what happens is the definition of an urban area gets bigger. Typically, people say, I'm happy to live and work 30 minutes apart. Feels about right, 30 minutes apart. 30 minutes apart becomes about 250 miles. So you can live in one place and work in another. Or as my friends in the UK say, what if you were to take the London Underground and drop it on the whole of the UK? You can also do some other things. What happens is that you get regional vitality. So in the UK, there's a big issue about the north of England not sharing in the spoils of London. It's one of the key reasons for the Brexit decision, actually, the haves and the have-nots. But if you can buy a house in Manchester for a tenth of the price of a house in London and still get to work in less than 30 minutes, you do a lot for regional urban regeneration. You also do a lot for real estate prices in the other area. Businesses form around the hubs, jobs move there, and as companies, you get access to much larger talent pools. So these are just a few of the examples of what could happen if we can eliminate the problems of time and distance. And then the final question before I get into manufacturing is people say, yeah, but is it more expensive? So based on about 7 or 8 studies that we've done worldwide, the bottom line is it's 3 times faster than high-speed rail because it doesn't stop. It has 3.5, 4 times the benefit of high-speed rail because it's what's called the wider economic benefits, or the payment, the availability payment that governments use to actually top up public infrastructure projects. It attracts a much higher benefit, which means the PPP, the public-private partnership funding, is much easier. But the main one is compared to high-speed rail, 30-year total cost of ownership, CapEx plus OpEx, it's about 2/3. Why? You don't have to buy the land, you just buy the holes to put the concrete in for the pillars, it goes there. Or if you do need to go into the city, it's a very narrow bore tunnel, so the tunneling costs are much less. OpEx, it only uses electricity for 10% of the journey. Once it's moving and it's gliding, turn all the power off, regenerates electricity when it breaks. So it looks like it's cheaper, it's faster, it's greener, and maybe it's a more effective alternative, but that has to be seen. In which case, if it's coming, and I'm going to come back to the is it coming, what could it do for your industry, or represented by the people in this room, which is supply chains? So the way we went about that is we said, well, let's look at the theory, and can we prove the theory? So we asked people, what do you think this could do? So when we asked them, they said, well, you could go to on-demand. I mean, we talk a lot about additive printing or 3D printing. We don't talk about revolutionizing supply chain and distribution. Maybe there's more opportunity in supply chain and distribution than in 3D printing because not everything can be 3D printed. But everything has to move if it's physical. So we could do on-demand delivery. I'll show you some data on that. Maybe we could go for centralized warehouses rather than putting warehouses near cities to meet delivery time SLAs. Maybe we can actually clean up the cities by taking the trucks out of the cities, get a much bigger pool for our workforce than just the local radius, and can we actually redesign our manufacturing hubs? So what I'm now going to go through very quickly is the data that we actually found to test the thesis. This is in a major report that we'll be releasing in about a week's time, and we worked with McKinsey on this. So I'll go through this. This is US data because that's where the most public data is available, so it's the easiest to look at. Total supply chain and distribution, $300 billion addressable market. 40 billion moves less than 30 kilometers, not the sweet spot, take it out. What you've got is about 115 billion, which you could move on a Hyperloop, but you really need to move oil and chemicals really quickly. No, you're not going to store them at the other end, so let's just take those out. But what you get is a big chunk. You get $145 billion. Let's make some assumptions on if there was a network. So what we wanted to do is create a network that would connect about 85% of the US population with 5 hours anywhere to anywhere. So less than half a day, obviously. That turns out to be 21 cities with 22 Hyperloop connections. So we assume that these things existed, and there's plenty of people in the US who want to go there. What would that do? So using the publicly available data, it looks like warehouse costs would come down by 25%. Now, why? So let's take a company that's very open with its data, which is Amazon. Amazon today have 109 warehouses. They actually use 3 sizes, small, medium, and large. Using this data and based on that assumption of a network, they'd be able to get, for the same delivery times, a reduction from 109 down to 18 or 6 clusters. That would give them a one-off saving in inventory of 1.6 billion and an annual saving in inventory depreciation of $390 million. That's for one company. Admittedly, a big one. Let's look at talent. According to data from Manpower, 40% of employers in the US say that they're short on talent, and the primary reason, 25%, they're just not getting the applicants. So let's look at another company now. This is Boeing. Up there, the dot, that's the world's largest manufacturing factory. And in fact, having visited Strata in LA, making a lot of the components that support that. So right now, most of the people who work for Boeing come in from about 60 miles apart, because otherwise the commute's terrible. If there was a Hyperloop, of course, the 1-hour commute becomes 700 miles. You have to make certain assumptions on connectivity, but broadly, certain big cities suddenly become available for where you can live in a city, work somewhere else, and get back home for dinner. Maybe you don't want to do that. Maybe what you actually want to do is take your big manufacturing hub and distribute it into smaller places where land is cheaper. There's a 80% decrease in land costs within that circle on that. So this has enormous opportunities for how people move, where they work, where they live, and where factories will be placed. The biggest single one is trucking. Give you a data point. World's biggest retailer, Walmart, sell $100 million a day. It's a wonderful statistic, but $200 million a day of stock is moving on trucks in North America. Twice as much as what they sell is on trucks at any one time. In fact, taking US trucking, it's growing at 5% compound, which by 2045 will be a 40% increase, so there's going to be 40% more trucks. Maybe convoying will help. The cost today of road maintenance and congestion is estimated by the US Department of Transport to be $1 trillion or 7% of GDP. So this is a big low-hanging fruit if we can do anything. Taking 2 of those routes and analyzing them in detail, where the thickness of the line shows the number of trucks, et cetera, what we find is that on the Dallas to Houston, it will be 2.5 hours faster. And on the Boston to Washington, this is the big prize. If any of you know that corridor, it's very intuitive. 6 hours faster. Taken as a whole, there's the opportunity to eliminate 6 million truck journeys or give back 37 million hours of time. Now, clearly, they won't all happen at once. But the effect on roads, road maintenance, the road experience, green pollution of this is absolutely going to be significant. And this is what is driving. Trucking is the thing that is driving Hyperloop interest. Let's take another one. What about same-day delivery? Today, Amazon offer same-day delivery to 66% of the US population through Amazon Prime. With the Hyperloop network, that goes to 86% at lower cost. So SLAs become bigger. Let's take another example, freight. We've formed a very deep alliance with DP World. Their chairman is on our board, Sultan Bil Suleiman, and they have 77 ports worldwide, and we're looking at what could we do for ports. Now, remember, freight grows at about 5% a year. They take the containers off the ship, they put them on the ground, they all pile up on the ground like lots of Lego bricks, and then they truck them out, often through the city. So as freight grows, what happens is the amount of space you need at the port grows. The problem is land is really expensive. Now, this is not a DP World port. They have 77. This is a different one, a study that we've done in the US, Port of LA, Port of Long Beach. But what's happening is the average time taken to get through LA to the port is now 80 minutes. So what people want to do is create a dry port, take it off the ship, take it 50 miles inland, then unload it. So you can then free up the space in the port. Trucks don't have to drive through. Trucks don't have to drive back. By 2050, 4x increase in freight means they're going to need 4 times, well, an incremental 4x for that land. It's just not available, and it's extremely expensive. Most ports, of course, are surrounded by cities. Taking it as a whole, the white paper that we'll be releasing sort of sums it up into these groups. Opportunity for about 25% of finished inventories, access to 10 times more labor, definitely shorten lead times and reduce freight spend, particularly around trucking. Massive implications on CO2. I saw the keynotes this morning, 50% target for carbon reduction in this region. This is one of the biggest single things that can happen, is take the trucks off the road and then use land. There's a lot of cheap land in this part of the world and other parts of the world that could be used to actually save on real estate. Build new smart cities where people can commute to the existing cities in 30 minutes or less. So I want to finish with the question that I set up right at the beginning, which is paraphrased as, yeah, but really? Is it really going to happen? Is it really going to happen? Well, the honest answer is we don't know because it hasn't happened yet. But we've got a pretty good idea that it's likely to happen. So let me present the case that it's likely to happen. First of all, what happened after the white paper? So our chairman was actually flying with Elon, said, can I have a crack at doing this? Can I have a go? He said, sure, have at it. It's open source. We started in the garage, the garage, as the Americans say. We are now about 240 people spread across 3 campuses. We think we'll be about 500 by the end of this year. A lot of people have come from SpaceX, aerospace industry. A lot of the engineers came from the team that created the Falcon 7, the rocket that goes up and lands vertically. So there's some really interesting conversations with those guys. You may recognize this picture. We did an open-air test of our linear motor. This was the second most watched video on the internet last year. We had 34 billion impressions of this short video just to test the motor. We're now on version 7 of the motor. That was version 1. There's a lot of engineering here. We have a 105,000-foot factory, which is building the components to create the world's first Hyperloop. And that factory, again, all the components are assembled there. That's actually vacuum technology you see in the bottom right. And everything was geared towards our strategy, which is different to other Hyperloop companies' strategy, but our strategy is we're going to prove it. We're not going to ask a country to prove it. We're not going to ask a partner to prove it. We're going to use investment, venture capital money. We're going to build a Hyperloop and prove it. So rather than me just say we're going to do it, I think video speaks louder than words. So what I'm going to do now is ask them in the back to queue up a video. It's our CTO who came from SpaceX, and he's going to give us a little tour of actually what's gone on in our site in Nevada. So can we queue up the video, please?
So here we are in North Las Vegas, standing at our test and development site. For those of you who've followed us for a while, you remember last May we did a propulsion system test. It's about 3 kilometers south of here. And here we are standing at DevLoop. So less than 6 months ago, this was nothing but barren desert, and we were just starting to build this. In the last 6 months, the team has worked through rain, through sleet, through snow to actually build this first test bed towards our Kitty Hawk moment. In a few short weeks, we'll be testing in here for the first time. We can't go inside right now. We're still a bit in stealth mode, but we want to give you a bird's eye view of exactly what we've been working on so hard for the last couple of months. Just to give everyone an idea of how far we've come in so little time, here you're looking at the same site less than 6 months ago when we began to pour our first columns. And then just 3 months ago, we started tube installation, sometimes 2 a day, welding them through the night. Then our vacuum pump arrived, which we've been working on over the past few weeks. And in fact, we fired it up for the first time today. So the team is excited to start testing. That's the update from DevLoop. So back to you.
So to take this to market, a series of partners, the best in class. We've got several partners. We also have AECOM, not mentioned here on the slide, working a lot with Parsons, who are here in the audience. But it's an ecosystem of partners who obviously want to be involved in this business and are aligning their resources to support this. I'll finish just with a couple of photos and another quote from the book. This was December the 20th, 1903, when somebody proved something that nobody thought was possible, which was the first heavy-than-air flight. And it went about 220 feet, and out of that grew the airline industry. It was on Kitty Hawk Beach, North Carolina. Josh talked about our Kitty Hawk moment. In the next 2-3 months, we'll have our Kitty Hawk moment. It'll be a public event where we actually run pods, not passengers, freight, down this tube. Actually, be longer than that, still building. And we think that's a pretty historical event, at which point we will have proved the technology: vacuum, motor, levitation, gliding, slow down, and critically stop. The question then becomes, what's the opportunity? So to finish where I started, Parag goes on to say, we should reimagine how life is organized. As we approach universal infrastructure as well as digital connectivity, what if the supply of everything could meet the demand for everything, and anything or anyone can get nearly anywhere, both physically and virtually? He calls this a supply chain world, and it's described as the biggest opportunity for business model transformation, societal transformation, your own life experience, since the digital broadband revolution and the internet revolution of the last 30 years. And I think for this audience, it's a particularly appropriate message, and it's a particularly exciting time as we are just about to actually prove that this is possible, and with all of the activity that we've got here in the region. So with that, thanks for your attention, and I think Simon is here. You're going to come back up. Thank you very much.
Thanks, Nick, for a very interesting presentation. It seems like a technology that could change the way that we organize ourselves. One question that I had was, I mean, right now cities tend to form in places because maybe they're near something that people want, maybe near a resource or a geographically convenient point, or a place where there's workers of a certain type that perhaps firms want to use. So there's some sort of factor that causes a city to form. Now, in the Hyperloop world, actually you don't really need cities anymore, right? So those agglomeration factors, you can be hundreds of kilometers away and still reach there. So what does this technology mean for the future of cities? Do you think it means there are fewer and fewer cities as we can all congregate in maybe the places with the nicest climate, or the world goes back to a rural area?
Yeah, no, I don't think either of those two. In fact, I would push back on the assertion and the assumption behind your question, which is probably why you asked it that way. Actually, historically, if you look at how cities formed around towns, and towns, if you take North America, towns formed around the railroad. So the advance of the railroad, actually, you can plot the cities in the US from where the original railroad was, and you have the ports as well, as I mentioned. Mm-hmm. I think we're going to have more cities, not less, but we're going to start to have the opportunity to reverse the mega city. All around the world, people are moving, as you said, from rural areas to mega cities. I was in India recently. A number of people who were living there just because they have to come to the city because that's where the jobs are and the commute is. So I think we have an uneven society. I mentioned Brexit. You could point at other political events around the world. The gap between the haves and the have-nots is actually widening. The cities are getting bigger and they're under strain. Mm-hmm. So you asked the question, what would it mean for cities? I think there's an opportunity to build new smart cities, which is another subject, which are actually 200-300 miles away from existing cities, and you can still get there in half an hour. So we have a number of conversations, and by the way, real estate developers are really interested in this, a number of conversations with people saying, I could build a smart city actually between these two major cities and actually move people out and attract industry in. So my own view is that actually you'll get more cities, but it'll be more evenly distributed, and you won't get this have and have not world, which actually has not only social implications, but very clearly political implications, as has been shown either between north-south divides or coastal divides and the Rust Belt.
Yeah, I mean, it could be very transformative. Many things for us to discuss in the future, particularly if we do see a Hyperloop project come off soon. And yeah, I hear that Abu Dhabi, Dubai is in the running. So maybe in the next GMIS in 2019, we'll be able to use it.
That'd be nice.
Thank you very much for coming on today. If everybody could thank Nick, please. Thanks very much.